let's start this mock interview series. My name is Shazib. I'm a process engineer. I've been doing this smart process engineering mock interview series from last year. And today we have with us Rizwan Liaquat as a candidate who is a senior process engineer working in agropolymers and chemicals. He will introduce himself when the interview is being started. Today we have an interviewer of which is going to lead this interview is Bernard Osiron. And let's introduce Bernard Osiron. Bernard, can you introduce yourself? And then Iswan will uh, reply you back. Thank you.
Yes, good afternoon.
Good afternoon.
Can you hear me well?
Yeah, perfect.
Thank you. My name is Bernard Osiron, and I'm a practitioner of chemical engineering. I have expertise in manufacturing, process engineering, project management, engineering procurement, contract management, operational excellence, and business and financial strategies. I'm really very happy to be the leader of today's mock interview. And just to give you a brief, the purpose of this interview will be to evaluate the core competencies that compose you as a senior process engineer. So just feel at home as we discuss, and it's a learning platform as well. I had an opportunity to look at your CV, but that doesn't prevent us from giving you an opportunity to introduce yourself. But before you introduce yourself, we have together with us some guests that I would like to invite and briefly introduce themselves. And then following their introduction, you will go ahead and introduce yourself, highlighting your education background, your experience, and some of the key skills that you have attained as a process engineer. Please, let me try to invite Nelson. Can you give us a brief introduction of yourself?
Good afternoon, members.
Good afternoon.
I am here.
Very well.
Nelson Owino is my name. I am an industrial chemist, and my expertise is manufacturing, process improvement, process optimization, and quality assurance. Recently, I'm a certified quality management system practitioner, environmental management system, and also professional health and safety, and an internal auditor certified. So I have certifications in white belt and black belt, currently practicing from Uganda.
Thank you, Nelson, for that brief introduction. We are happy to have you on this call.
Thank you, sir. Thank you.
Thank you.
Joseph, please, you have the microphone. Joseph, are you on the call with us? I think Joseph is a bit distant from his laptop. Please, can you go ahead and introduce yourself?
Okay, to introduce myself, my name is Rizwan Liaquat, and I am from Pakistan. I'm a chemical engineer by profession, and I possess 8 years of experience as senior process engineer in Pakistan's largest petrochemical plant, that is Agro-Polymer and Chemicals Limited. I have strong technical and analytical skills, and I'm the pioneer of major technological advancements, especially the implementation of energy management program at Agro-Polymer. I'm very enthusiastic into learning and to the professional well-being of the people. And like every passionate engineer, I also possess the same courage to cherish my career and to keep myself grow. So that's all about myself.
Thank you very much. Pronounce your name again. Is it
Rizwan? Yes, Rizwan.
Yes, Rizwan. Yes. We are happy to host you today in this mock
you.
interview.
Okay, thank you.
Just to re-emphasize on the purpose of this mock interview,
Okay.
is basically to evaluate on your core competencies as a
Okay.
senior process engineer.
Sure.
And from your introduction, I have understood that you are working in a petrochemical plant.
Yes, exactly.
Which one is it basically? Is it the VCM, PVC, or DC?
Okay, so I have worked on 3 units. Initially, I was at the caustic soda plant, and then I was moved to the utilities and power plant. There I worked for like 2 years, and currently I have been assigned in special projects on the EDC and VCM plant. So I have kind of worked on 3 plants in this complex.
Okay, just to build the context around that same area, in a chemical plant, specifically the petrochemical plant, we have reactants.
Yes, yes.
We have reactants that are reacting. Reactor A plus reactor B.
Okay.
I mean reactant A plus reactant B, and they are giving us products B, I mean C and D.
Yes,
C
exactly.
is our desired product, and D is the undesired product. So because we have these products together, we separate them. We get the desired product from the undesired product.
Yes.
So after separation, we purify the desired product, and then we treat the undesired product, maybe for reuse, for recycling, or for disposal. Now, as a process engineer, one of the key aspects that we look at is optimizing the output for the desired product.
Exactly, yes.
Is that true?
Yeah, exactly. You are completely into it, yes.
Using the same analogy, I would want you to take us through an understanding of what happens in the VCM plant.
Okay. So at the EDC VCM plant, when we produce the VCM from EDC, there's a process which we call as the cracking. So the cracking of EDC produces VCM. So as a byproduct, there are 2 things which are produced. One is the production of HCl, which is an undesired product. So the other is unreacted EDC. Okay, so our purpose, yeah, okay.
Just to take you back a bit, I would want you to start from the EDC. How do we end up with EDC? How do we get EDC before VC?
Okay, sure.
And,
so,
and the guests would want to understand what is EDC, what is VCM. We are using these acronyms, but what are they in full?
Okay, so the basic process starts with chlorine gas, which comes from the caustic soda plant, and from the ethylene gas, which we are currently importing from Gulf countries. So the ethylene gas and the chlorine gas are combined in a reactor that is a low temperature chlorination reactor. There an exothermic reaction happens, and a third product is formed, which we call as the ethylene dichloride, or EDC. This EDC is first passed through a series of washing units to remove the undesirable iron chloride, and also to balance the pH. And then this EDC, which we call as the raw EDC, is sent to a purification unit, which has 3 different purification distillation columns, where different light components, heavy components, and other undesirable components are removed. When this EDC gets purified and is now free of moisture and any other impurities, this is then pumped into a cracking furnace, where this EDC is cracked into VCM, which is our desirable product. So in the cracking process, there is a byproduct which is called the HCl is formed. This HCl, we have to, obviously we can't discharge it into the atmosphere. This is a hazardous compound. So all we can do is to recycle or reuse this HCl and to reconvert this HCl into EDC. So for that, we have an oxy reactor where this EDC is this HCl is pumped into, and there we introduce ethylene gas and reactant, which is called as the oxygen, pure oxygen. So all these 3 reactants in the presence of a catalyst, which is a copper chloride, they react and they again produce the EDC. So this anhydrous HCl is 100% consumed. And the valuable product EDC is again formed and sent again for the cracking to produce VCM. So this is kind of a cyclic process that goes on and on and on, so that we have the maximum production of VCM from EDC. So that's a whole kind of, you can say, process and optimization.
Okay, thank you. Could you please categorize that entire value chain into unit operations and unit processes?
Okay, so the unit operations are primarily the physical processes. For example, distillation is a physical process where by the application of heat, we separate the components based on their boiling points. While, as I mentioned, in the auxiliary reactor, there is the formation of a third chemical from the reaction of certain 2 chemicals or 3 chemicals. So that is kind of a chemical process. So where reaction chemistry is involved, there's a process. And when there are physical operations like pumping, compression, separation is involved, that we call as the unit operations.
Okay, now let's look at the formation of EDC. From your explanation, you talked about chlorination and then oxychlorination.
Yes,
True?
yes, exactly, true.
What's the purpose of oxychlorination?
The purpose of oxychlorination is to basically convert HCl from the cracking furnaces back to EDC. So that's kind of a byproduct reutilization reaction.
Now, is that chlorination reaction exothermic or endothermic?
Okay, so the chlorination as well as the oxychlorination reactions are highly exothermic. So in one of the reactors, we use the cooling water to remove this exothermic heat. And in the oxy reactor, we produce steam from this heat. So that's kind of a more, you can say, economical operation.
What's the purpose of cooling water?
Okay, the purpose of cooling water is to remove the heat of exothermic reaction to keep the reaction in the forward direction.
Okay. Now let's look at the cracking step where EDC is converted to VCM. VCM is vinyl chloride monomer.
Yes.
Okay.
Yes.
There is quenching.
Yes. Yes.
What is it and why do we quench?
Okay. So basically, when the VCM leaves from the furnace, the cracking furnace, the temperature is about 515 degrees C. That's a desirable temperature for cracking. So after that, there's a unit called the quench unit, where we suddenly reduce the temperature of this outcoming stream from 515 to 215 degrees C. The purpose is to cool down the products so that they do not further convert into byproducts, or they cannot be able to promote the formation of heavy products, heavier compounds. So that's the purpose of quenching, to basically halt the reaction.
Okay. So we quench basically to make sure our product of interest does not decompose further.
Yeah, further or into undesirable products.
Okay.
Yeah.
Now, as a process engineer,
Yes.
what key thermodynamic parameters do you monitor and control?
You are asking about the dynamic parameters that are important to control, right?
That you control, that you monitor and control, not just important.
Okay, so the important parameters in every process are the pressure, the temperatures, the flow rates. We always try to keep them within the design or the optimum values or limits. I have also worked on utilities and power plants. So there are other additional things that we control, and that is the consumption of electricity. And for example, the consumption of the utilities that contribute for the smooth operation of the plant. For example, the cooling water, the steam, the instrument air, the plant air. So their consumption is also of importance. So at the process plant, usually there are flow, temperature, pressure. These are the important parameters to control and to monitor.
Okay, just to take you a little bit back, the ethylene.
Yes.
Right?
Yes.
It comes at a very low temperature, right?
Yes.
Why?
Okay, so obviously, as I said in the start, that Pakistan doesn't have its own ethylene, so it comes from Gulf countries, or let's say from sometimes from US as well. So to increase the to decrease the volume, so that more quantity can be shipped in certain vessels, they try to keep it within the liquid state. So to keep it in liquid state, obviously you need cryogenic or very low temperatures. So obviously that facility is not part of my plant. We have another subsidiary that we call as the Angro Vopec terminal. So there this liquid ethylene comes, and then they have vaporizers, and they then send us that vaporized EDC.
Okay.
Sorry, ethylene.
Now,
sorry.
yes, process engineers
Yeah.
or chemical engineers, by training,
Okay.
they are problem solvers.
Yes, no doubt.
Do you agree?
Yeah, I'm very good at that.
Have you gone through the process of problem identification, problem solving? Have you?
Yes, multiple times.
So,
like, yeah.
Okay, so I want us to talk about problem identification, and
Okay.
basically in regard to the plant that you're working on. Could you tell us the problem that you recently identified, highlighting the steps you undertook and some of the tools you used to clearly define the problem that you worked on?
Okay, so like everybody, I would also say that I use the root cause analysis techniques. Multiple techniques are available. For example, the fishbone diagram, the fault tree analysis, and the tools like this. If you will ask me honestly, so my biggest weapon always have been to talk with the people who are experienced and who have been into these circumstances before. So the operators, in my theory, it's very important to talk, not to the people who are experienced, but also to the people who are beginners and learning the processes, because they are at that time they are going through certain manuals. They might tell you that somewhere this is written that this is the troubleshooting step. So the vendor manuals, you can't exactly remember them all the time. So it's always helpful that you talk with the experienced people, you talk with the learners, and you actually go and visit the area to see the actual problem. So my theory always have been to firstly to have a very broad look at the problem, to apply certain techniques, and then go into the physically into the area and talk to the people that what is their opinion. So when I connect the dots by taking advice from everybody, so it ultimately leads me to the conclusion.
That's so wonderful. In problem solving, actually in operational excellence, there is a tool called, it's a Japanese word called Gamba.
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 Okay.
Do you know what it means?
I have heard about this before, but I don't actually recall its meaning.
Gamba is exactly what you've explained. You have to go to the real place of work.
Okay.
And know what is happening, interact with the people who are working on that process. Now,
okay,
usually,
I'll study about it.
Yes. Now, usually when you do that practice, it's a good one, but in most cases, it will give you qualitative data. They'll just say you there is a problem here. How do you determine the magnitude of that problem? Because when an operator tells you that we are experiencing high defect rates, that is qualitatively stated. But how do you then determine the magnitude of that problem?
So initially, obviously, to understand the depth or to understand the magnitude, I will first apply the 80-20 rule. I will, segregate the useful data from the available data. So at that, I'll start to make relationships and the trends, maybe on Excel, on certain analytical tools. And then again, by looking at the trends of the various parameters, I can observe that which of them is causing the problem. So obviously data filtering is important, data analysis is important. For that, you need to have certain tools. The knowledge of those tools is important. And then you can actually, it's very important that you can connect, somehow you can connect or build the relationship between the parameters. So that can help you come to the conclusion.
You've talked about the 80-20 rule. That's the Pareto analysis, right?
Sorry, come again?
80-20 rule.
Yeah, 80-20.
It's the same as Pareto analysis.
Yeah, it's kind of a thing that helps you to filter the data and to shift your focus onto the things which are actually important.
So that's the concept of statistical process control.
Yeah, statistical process. Okay.
Yes. Okay. Because you're dealing with the statistics.
Yeah, statistics. Yeah.
Okay. Now, as a process engineer, I would want you to tell us, because we have understood that you are a problem solver. That's primarily your basic role. Now that you've identified the problem, how do you go about it?
Okay, so once someone identifies a problem, so he or she should raise the level first to tell to the relevant stakeholders about the problem, its depth, and the strategy to solve it. In my organization, it's not every time it's not appreciated if I tell them the problem. So they always, kind of ask me the solution to that, because, they always expect me not to come with the problem, but with the solution. So obviously I'll make a very good presentation on the root cause analysis, but the key thing that they would expect me is to bring a solution. So that's my ideology.
Okay. Process engineering in an industry like a petrochemical industry is two-way.
Okay.
You go into operations to understand how the plant operates.
Okay.
And possibly to identify possible areas of improvement.
Exactly.
Then the other part is backward application of your skills to design processes, to optimize processes, to improve processes.
Yes.
So that takes us to the knowledge of process design.
Process design.
And plant design.
Yeah, by the way, sorry to interrupt, but
Please.
right now I am working in the capacity of process design engineer. Initially, I was a plant engineer, but since last 1 year, I am working as design engineer because I'm working on long-term reliability projects.
That's good. In your introduction, I got to learn that. That's why I first wanted to understand your insights, to get insights from you in regard to process operation. And now I'm going to your exact area that you've talked about.
Okay.
So,
okay.
In planting, usually we encounter process design and then plant design. How are these different?
Okay, so
what's the difference between process design and plant design?
Process design. Okay, so in my opinion, the difference is when you are working on the plant as process engineer, so you are kind of an auditor, and you're kind of a person who troubleshoots and who makes sure that the profitability comes through the optimized operations. So that's your job role in that. Okay, when you come into the head of a process engineer, so process design engineer, when you work in the capacity of process design engineer, so your whole job becomes to basically upgrade the technology and to bring the solutions which can actually improve your design. For example, it may be related to improve the safety of your plant. For example, you may go for the fire water network analysis to see whether your network is adequate to handle the single largest fire. You may be assigned to basically look at the process safety of the plant. You may be assigned to basically upgrade the metallurgies of the plant. So in that capacity, you are not looking at the plant while you are working with the designers. And you are basically interpreting your plant to the designer, and you are basically evaluating the best which can be done with the plant to improve its reliability, to improve its service factor, to improve its design. So that's my view on process design engineering. So obviously we're not designers like the way they have in the design houses. We are the interpreters of our plant to the designer.
Okay, I want us to understand this from first principles, right?
Okay.
Why, or under what circumstances do we carry out process design? There are basically two.
Sorry, come again. I missed your question.
I'm asking.
Okay.
Under what two different circumstances do we perform process design?
Okay, the one is that your design is not adequate and you are having lots of troubles with your existing plant, and you might see that there's an improvement which must be studied and to be implemented. Okay, and obviously the second thing it could be like there's some new technology in the market and you are obsoleted. So obviously you want to study that, would that be applicable to my situation, or would that be profitable to implement? So that could be two situations.
Okay. And now when we get into process design, we are usually solving a problem, an engineering problem. So we usually encounter terminologies like process simulation, process improvement, process optimization. Can you try to build some context around these terminologies to make us understand from an engineering perspective?
Okay, so process optimization might come from if I give you an example that I have a unit in my plant, and that is installed on the downstream of oxychlorination reactor, and the purpose of that is to basically recover the EDC, which otherwise will be wasted, because the stream which the gas stream which leaves the oxy reactor contains some EDC. So my objective is to recover that EDC, which otherwise will be sent to the incinerator and will burn as fuel. So EDC is my precious product, so I want to recover that. So there is one unit installed, absorber stripper unit already installed. So I'm a process design engineer, and by experience I have been told from the plant people that the service factor of this absorber stripper unit is not properly met, and because of that the units remain shut down for like 6 months, and that results in the loss of a lot of EDC, and we have to we have to send this EDC to the incinerator. So I, being a process design engineer, will evaluate that what other possible design improvement I can make. So let's say I studied that a chiller system instead of this absorber stripper unit system can not only increase the recovery, but can also operate more reliably than this absorber stripper unit. So that would be kind of an optimization and design improvement that I will make into my existing process. Because obviously for a problem, there are multiple solutions available. You'll just have to identify that which can fit into my existing infrastructure. So that could be one example of process optimization and process design improvement. The other thing is, for example, I have pressure relief valves on my plant, and they are open to atmosphere. Those relief valves, when will release the chemical into the atmosphere, they will expose the community around my plant with the toxic chemicals. So I will study, let's say I will conduct the dispersion analysis of the stream that ultimately will be omitted from that relief valve. So based on my simulation work, I can predict that how much it can affect the community around me. So I might go for installing a scrubbing system where that outlet of the PSV will be routed and will ultimately be neutralized before ultimately going into the atmosphere. So that is something which is related to the improvisation, or you can say enhancement of the safety of my plant. So there are multiple dimensions where we can work in process design.
There is a process modeling. Are you familiar with it?
Yeah, process modeling, I'm familiar.
And the simulation, right?
Yes.
What is this modeling? What is it in a nutshell? What is process modeling?
Okay, so process modeling, either steady state or dynamic, it basically allows you to study or learn your plant in an anticipated or forecasted way. Like you can predict something. Like for example, if I want to study that if the composition of my feed stream changes, so what will be the impact on product quality, or what will be the impact on the operating parameters of my reactor? So that basically gives you an anticipation to look into your process and to basically identify the optimization opportunities.
We were still talking about process design. Have you recently undertaken a new project, a new engineering design project?
Yes, I'm actually I'm working on 5 projects at this time, and one is very interesting, and it's a brownfield project, and that is to basically upgrade the metallurgy and size of the critical heat exchangers at EDC plant. And a third-party engineering company is doing that detailed engineering work, and I'm kind of a design review engineer because I approve the design for process and some part of the mechanical as well, because I have a team of mechanical engineers with me. So I am working as a lead in that project. So I'm not only I'm reviewing the process design, but some part of the mechanical design as well.
That's wonderful.
Yeah.
So you're familiar with the PFDs?
Yes.
And IDs?
Yes. Yeah. So one of my projects is also to upgrade or to update the PSI, process safety information package of the plant as well. So over the years we have evolved. We have done multiple projects at the plant. We have done multiple modifications on the plant, but we did not updated our basic process design package. So the information has now been outdated. So a task has been assigned to us where we are, we are building the PNIDs exactly as per the plant that we call as the as-built PNIDs. We are doing the 3D modeling of the plant. We are scanning the complete plant, and based on that scanning, we will build the isometrics of the plant. And obviously the other vessel data sheets, general arrangement drawings of the equipment, electrical layouts, instrument layouts, control well data sheets, everything which comes under this process safety information package that we are compiling. I have been given a team of multidisciplinary engineers. Like, for example, from instrument section, there's an instrument engineer, electrical engineer, stationary engineer, machinery engineer. So every engineer from every field is with me, and we are upgrading this whole process safety information package, because the information should be evergreen, because that allows you to take the right decisions. Otherwise, you may end up, taking a wrong decision based on the wrong information or the outdated information.
Okay, you've talked about safety, process safety
information.
Are you familiar with HAZOP studies?
Yes, I'm quite familiar with them. In fact,
what is it?
Yeah, okay. So when I was at the chlor-alkali plant, there we produce chlorine gas. So it's a highly hazardous process plant. So there we used to conduct these risk studies. We do it by different methods. One could opt for what if analysis. Other company may opt for HAZOP analysis. These are just different techniques to do the same thing. And currently we are into the RBA, risk-based analysis technique, and we are doing the PHA, or the process hazard analysis, on these risk-based approach now. So yes, I'm familiar, quite familiar.
Okay. Which software do you use?
At this moment, we only use the it's a tool called the DSS model, DuPont Safety Solutions. It's kind of an Excel sheet with a certain format that we follow for the HAZOP. In terms of softwares, I don't think that we are into any specific software for this PHA technique. But for the overall safety management, we have two software. One is called the Opera, and the other is Velocity. So we, every incident, every management of change, every PHA, even every HAZOP, ultimately is then approved through that platform. But in terms of exercise, we do it on Excel at this moment.
How about to process simulation? Which software do you use?
Okay, so we here at Anglo Polymer, we use the Aspen HYSYS.
What's the principle behind this software?
Yeah, so basically the principle is obviously everything comes with the properties of a chemical. So the software, what it does is it basically studies or basically identifies the reaction, the binary reactions, or other thermodynamic reactions through the use of certain property packages. So it can correctly identify the interactions between certain chemicals, which you can't do it on Excel. You cannot study the complete effect on the properties simply on Excel or any other tool. So it basically gives you details on the interaction of certain chemicals. So that's the basic concept behind those simulation softwares, is the property package that they provide. The other thing is quite obvious that you can you can simulate various scenarios on those softwares. You don't need to basically build the model each and every time. You can build a basic model and you can play with that in different situations. So that's the basic thing that software provide.
Okay. I want us to talk about P and ID. You've talked about the interfaces you have with the other engineering disciplines, engineers, mechanical engineers, electrical, instrumentation and control.
Yeah.
And one of the key documents from process engineering is the P and ID.
Okay.
Right?
Most important
there is always a confusion that engineers encounter.
Okay.
In operations, you find PID.
Yes.
In design, you find P and ID.
Yes. Okay.
What's the difference between these two?
PNID and PID.
Yes.
So PID is kind of a pressure integral derivation. That's something that is used to tune a process control loop, if I understood correctly. That they're asking. It's something related to the instruments, and you always want to make your loop very sustained and smooth. So for that you adjust several parameters, and you set the PID settings of the controller to make your loop reliable and smooth. The PNID is, on the other hand, is a document. It's a document that contains certain valuable information about the plant. For example, it contains the lines, the pipelines, what is inside the pipeline, what is the size of that pipeline, what is the material of that pipeline, whether that is insulated or not. It also contains information such as how many valves, either manual or control, are installed, how many instrumentation is installed, how that instruments are connected with the DCS. Like each and every information that you need to know about the plant can be found on the PNIDs, except for the dimensions, because it does not tell you that how long the pipeline is. For that, you need to go to the isometrics. So I hope I answered correctly, because I understood PID and PNID.
Yes, you have. Now, looking at the P and ID, which is the piping and instrumentation diagram. Yes. Usually in design, this is issued like with reasons or with purposes, and there are always three. Do you get what I'm saying?
Sir, can you repeat? Actually, there's some internet issue. Can you repeat?
I'm saying P and ID in process design. Okay. It is usually issued in phases, and each phase serves a different purpose. And there are three stages.
Yes, exactly.
What are these three stages, and in each stage, what is the purpose?
Okay, so firstly, there's issued a basic design package, and the PNID is part of that package. The purpose is to conduct the hazard analysis or the HAZOP. And
just a moment, just let me, sorry to interject. Let me try to clarify the question. Okay. P and ID can be issued for review. Can be issued for construction.
For construction, yeah.
And can be issued for design. Yes,
exactly. So
are you familiar with those three?
Yeah, these are the three. Like initially it's issued for design, detailed design, then is issued for construction. And once the construction is complete, there's another set of PNID that is called the as-built, because during the plant construction there are few changes which are made, so you want to capture those changes, and that changes are captured in the as-built PNID.
Okay.
Yeah.
Now, as we wind up your technical evaluation, every organization, profitability is one of the primary objectives.
No doubt.
Now, from our discussion, I want you to summarize very briefly, how does a process engineer contribute to the profitability of a company?
Okay. So if you will ask me, I would say that the process engineer is the only person on the plant who thinks about economy. The others always think about maintenance. So how we ensure that is, obviously, we always in search of the most optimum economy point to operate. We are always in search of that, and we always in fight with our operations and maintenance guys to operate on that optimum point. So that is one point. The other point is we are always in search of the technologies that offer low operating costs, low variable costs. We are always into the optimizations. For example, at my plant, I have done so many retrofittings that not only enhance the safety, but also enhance the recovery and recycling of certain products. So we always work with the mind that we have to increase the profitability and to optimize the design and enhance the safety. So that's my take on this.
Okay. In addition to plant economics, what other key factors are important for process engineer, especially from a design perspective? Consider.
The most important thing is process safety. It should not hurt in any way. Obviously,
yes, that's what I wanted to hear. That is all, process safety.
Yeah. Obviously, that's always a priority. Nobody can, on the petrochemical plants, you cannot live without that, because you're also going to the same plant every day. So you always want to make it safe and safer.
Okay, safety is second to none.
Yeah.
Now,
safety is the first.
I want us to talk about your leadership. As a senior process engineer, you told me you're leading a project, you have electrical engineers, you have fermentation and so forth.
Yes.
So I want us to talk about leadership as a process engineer.
Okay.
I want you to cite one scenario or one example where you exercised your leadership capability to solve an engineering problem which required interdisciplinary interfaces.
Okay. Scenario. Okay. So you want me to explain a situation where multiple interfaces have some conflict, or what?
Just cite any scenario, any scenario that you have undertaken or that you have had as a leader.
Okay.
Where you were working on a project,
okay,
which required the interfaces,
okay,
and there was some level of leadership potential that you exhibited to ensure that that objective of that project was achieved.
Okay, so as a leader, what's important for you is there are two things which are important. One is the timeline of the project. The second thing is the quality of execution. And third thing, if I don't count it as a key milestone, but for people it's also important, that is cost, obviously. So the project leader is always focusing on these three aspects. So while you're working with a variety of people, they always have conflicts with amongst each other, between each others, and sometimes with the leader as well, because the leader is always pushing them to meet the timelines and the quality standards and everything. So being a leader of the project, I always ensure that the coordination step doesn't miss at any point in time. The coordination between the teams is of importance. The clear demonstration of the expectations to the team is very important. That what you want from them, what is your expectation? Are the timelines that you have set are realistic? Is it causing any anxiety within the team that the timelines are not realistic, the cost is not realistic? Is there any challenge that is forcing the team to compromise on the quality? So being a leader, your task is to take all these challenges and to keep your team motivated. So that's something which is important.
Okay. And as the leader, you have the vision, as you've said. Can you please tell us your understanding of the current industry trend which is affecting the profession of process engineering?
Sir, you will have to repeat. Basically, there's some issue with the internet. I missed your voice at a point.
I'm saying leadership and the change management are intertwined.
Yes.
You can't avoid the change, right?
Yes.
but at the same time, you have to deliver on your objectives. So looking at the industry today,
Yes.
and as we anticipate, which factors are emerging and are impacting on the profession of process engineering?
What factors? Actually,
what emerging technologies?
I'm trying to understand the context of your question, basically. So you are asking in general terms that
Yes.
what challenges process engineering would face
Yes.
in the years to come, right?
Yes.
Okay. Okay. The very big challenge which I see is the inception of artificial intelligence. Obviously, the analytics, the people depend on us because we are very good at analytics. So obviously, software can do a better analytics than me. The only thing where we will survive is in comparison to the AI is our decision-making skills. Obviously, it's not that advanced at this moment that it can take the wise decisions. Because obviously, sir, you have also have experience of working on the plant. The plants are not, sustained or steady state operations. They are full of, up and downs, not only like on monthly basis, but on a daily basis. You have to take certain specific decisions, and those are very specific to your plant, not to, and they don't apply to a general category of plants. Like if you are operating a VCM plant and I am operating a VCM plant, we will face the dynamics that would be entirely different. For you, ethylene supply might not be a challenge, but for me, ethylene would be a major driving factor for my plant. So the dynamics on each and every plant, so the AI, I believe, would not be able to, to learn each and every plant in the world. So that's something that's my opinion, but obviously I don't know where it will end. But yeah.
So you've highlighted that artificial intelligence is one key issue that is affecting process engineering in the foreseeable future.
Yes, exactly.
And as a process engineer today, how do you strategize? How do you plan to ensure that you remain relevant in the foreseeable future and in the face of artificial intelligence, machine learning, data analytics, Internet of Things, digitization, to mention but a few? How is the profession, how is the practice of process engineering going to remain relevant?
Obviously, with the changing world, you will have to align yourself with the technologies that are coming in. So I think that we should appreciate that something something is coming, that with positivity in mind, I believe that it will help me out rather than taking out my job. So I and AI will go side by side. We will we will improve each other with time, and with my continuous learning of as you mentioned, that machine learning, the learning on the artificial intelligence, this is something which will keep me in the market, or otherwise I will be simply expelled out from my simple process engineering job. That's a fact. I cannot deny that.
Okay, as a process engineer, what is your plan in the next 5 years?
Okay, so when I was in the university, I was about to pass out. So my dream was to become, a researcher, to invent things. So, somehow I had to join the industry because of some financial reasons. So I came into the plant life, and I started working as a process engineer. And my whole job was to basically simply go and keep the plant in operation, to optimize, etc. Then I specially requested my boss, because that was something which was was in my blood. So I requested my manager to shift me in the design section, where I can go through some thought through process and can make the designs better. So to answer your question, I would say that I would proceed for research-based institutes in the next 5 years, because I have gained enough knowledge of the plant. So I would prefer that if some company which has a certain R&D department, or which have certain, even the process design section is also a good thing, where you can actually put your ideas into reality. So I see myself working as R&D engineer in the next 5 years, or at least in the capacity of process design engineer, not the plant engineer that I have worked already. So so that's my inspiration for now. Let's see how time takes me to.
Rizwan, thank you for today. Thank you for interacting with me. Thank you for that detailed insight about your core competencies. I would want to say this comes to the end of the evaluation with me. And at this point, maybe or otherwise, I would like to hand you over to Engineer Hassan for furtherance.
Thank you so much, sir. It was very nice talking to you. It was very nice session. I enjoyed it a lot. Thank you again.
Please, Engineer Hassan,
yes, Bernard, do you want to give him the feedback live, or you want to write in notes any improvements you see during the interview?
I can give him the feedback.
Okay.
Live.
Okay,
yeah,
Rizwan,
sure.
do you have any questions from Bernard, from me? What do you have? What do you think about this interview series? Do you have some good words that how it is helpful for you to give an interview in the future? Like, for example, you have an interview invite next week and you are going for an interview. So how do you feel right now? Pretty much confident from before?
Yeah. So I'm, I already said that I have enjoyed it a lot. So there were questions like which are asked, but we are not able to correctly. Sometimes it happens that we are not able to apprehend the questions properly. So in this session, I was kind of free to basically ask from Bernard to rephrase it, or clear me the context of the question. So that is something that I obviously I would ask Bernard to give me the feedback, that how does it affect the interviewer if I ask for if I ask him to reiterate the question, or to clear the context of his question, that how does impact to the interviewer. And obviously the details to which Bernard has been into was I wasn't expecting this to go too deep, but yeah, this was more than I was expecting initially. So surely I have enjoyed it a lot. So that's all.
Yeah, thank you so much, Bernard, for taking this time and giving us this kind of professional environment to Rizwan, that he can go further in this field. So thank you, everyone, and let's end this interview right now.
Okay, I'll be expecting the feedback. It would be very nice to have the feedback. Thank you.
I will give the feedback through Engineer Hassan.
Sure.
Yes.
Thank you so much. Bye-bye.
Thank you.
You're welcome. Bye.